7.3 goes over hyperbolas and finding your common difference with them and your equations or your formulas for them, or would be your constant difference. So the first thing that we're going to look at is what a hyperbola is. It's exactly like what you see here. It's where it looks like you have two parabolas that are going opposite directions of one another, so growing opposite directions. First thing that we are going to look at is that you have a center with these. You also have two vertices. Your center is right in between the two vertices, and the vertices is either the highest or the lowest part of the lines. Your branches are the parts that go off or extend from those vertex. You're going to use these in your formulas, which is what we're going to look at second. So the first thing that we're going to look at with your hyperbolas is your constant difference. You're going to use the formula that's similar than your one that you used with your ellipse, but instead this time you're going to have subtraction between the two sets of radicals and also the absolute value of it. So your constant difference, or D, you're going to use the formula, the absolute value of the square root of x1 minus x3 squared plus y1 minus y3 squared minus the square root of x2 minus x3 squared plus y2 minus y3 squared. So you need a first and a second focus point as well as another point on the hyperbola. If we look at example 1a, you're going to find the constant difference giving your f sub 1 as negative 5, 0, f sub 2 of 5, 0, and the point of 4, 0. So this is going to, top one, it's going to be x1, y1, middle one's going to be x2, y2, bottom one's going to be x3, y3. And we're just going to plug them into the formula and simplify. So we're going to have the absolute value of the square root of negative 5 minus 4 squared plus 0 minus 0 squared minus the square root of 5 minus 4 squared plus 0 minus 0 squared. So this is going to simplify to give you the absolute value of the square root of negative 9 squared. The 0 minus 0 squared is just 0 minus 0, or 0 squared, which is just 0, so we can eliminate that. Minus the square root of 5 minus 4, which is 1 squared. And then that 0 minus 0 squared, we can cancel it out. From here, we're going to have the absolute value of the square root of 81 minus the square root of 1. The square root of 81 is 9. The square root of 1 is 1. So that becomes the absolute value of 9 minus 1, which is the absolute value of 8, which means that your constant difference is just 8. For example B, you have your focus 1 of 0, negative 10, focus 2 of 0, 10, and your point of 6, 7.5. Again, use your formula, plug these in. Top one's going to be x1, y1. Middle's going to be x2, y2. Bottom's going to be x3, y3. So if we use our formula, we have D is equal to the absolute value of the square root of 0 minus 6 squared plus negative 10 minus 7.5 squared minus the square root of 0 minus 6 squared plus 10 minus 7.5 squared. So this is going to simplify to give us the absolute value of the square root of negative 6 squared plus negative 17.5 squared minus the square root of negative 6 squared plus the 10 minus 7.5 is just 2.5 squared. So again, keep simplifying this. We're going to have the absolute value of the square root of 36 plus 306.25 minus the square root of 36 plus 6.25. This then simplifies to give you the absolute value of the square root of 342.25 minus the square root of 42.25. If you were to use a calculator and simplify this, you would get the absolute value of 18.5 minus 6.5, which is just the absolute value of 12. And that gives you 12 as your constant difference. For example C, we're given the focus 1 of 9, 0, focus 2 of 9, 0, and the point -6, 15. So your top one is going to be x1, y1, middle is going to be x2, y2, bottom is going to be x3, y3. Use your formula, plug these numbers in. We're going to have d is equal to the absolute value of the square root of 9 minus -6 squared plus 0 minus 15 squared minus the square root of -9 minus -6 squared plus 0 minus 15 squared. So this is just going to simplify to give us d is equal to the absolute value of the square root of 15 squared plus -15 squared minus the square root of -3 squared plus -15 squared. Simplify this even further. You're going to get the absolute value of the square root of 225 plus 225 minus the square root of 9 plus 225. Add underneath each radical. You're going to have the absolute value of the square root of 450 minus the square root of the 9 plus 225 is 234. From here, you are going to simplify these, and that's going to give you d is equal to the absolute value of the square root of 450 is 21.2132, and the square root of the 234 is going to leave us with 15.2971. From here, we're going to subtract these. And this is going to leave us with the absolute value of 5.9161, which is just 5.9161. The other part of your lesson deals with the equation of a hyperbola. Similar to the equations of ellipse, you're going to work with x squared over a squared and y squared over b squared, or y squared over a squared and x squared over b squared. However, your sign in between them is going to be a negative. So with these, you're still going to work with the vertices to see whether or not you're using the x squared over a squared or the y squared over a squared. And it depends on what or where the number is in your vertices. So if it's something comma 0, it's in the x value, you're going to use x squared over a squared minus y squared over b squared is equal to 1. If it's 0 comma something for your vertex, you're going to use y squared over a squared minus x squared over b squared is equal to 1. So with these, you're still going to use your focus and your covertices. Focus is going to be C, covertices are going to be B. Same thing with your ellipse. The only difference with this one is if you're missing an A or a B, you're going to use A squared plus B squared is equal to C squared to find one of those. Okay, so if you're missing A or B, use the A squared plus B squared is equal to C squared. If we look at the first example, we're writing the equation in standard form for the hyperbola that works with a vertex at the ordered pair 5, 0, and then a covertex of 0, 3. So it tells you that your vertex is the ordered pair 5, 0, and your covertex is the ordered pair 0, 3. This gives us both A and B. A is 5, B is 3. We know which formula to use because A is in the X value. So that means we'll use the formula X squared over A squared minus Y squared over B squared is equal to 1. Plug in your A and B and then simplify. So it's going to give you X squared over 5 squared minus Y squared over 3 squared is equal to 1. This just simplifies to give us X squared over 25 minus Y squared over 9 is equal to 1. For example B, you have a hyperbola with a center of 0, 0, the vertex of 0, 12, and the focus of 0, 20. So this one gives us a vertex and a focus, so we have our A and our C. To find B, we're going to use A squared plus B squared is equal to C squared. So that means we're going to have 12 squared plus B squared is equal to 20 squared. That simplifies to be 144 plus B squared is equal to 400. Move your 144 over by subtracting it from both sides, and you get that B squared is equal to 256. You could take the square root of both sides and find B. However, it's not necessarily because you're going to use B squared in your formula. Looking at your vertex, that vertex has a number in your Y value. So you're going to use Y squared over A squared minus X squared over B squared is equal to 1. So it's going to give us X squared over 12 squared, or sorry, not X squared, Y squared over 12 squared minus X squared over 256 is equal to 1. Simplify that 12 squared, and you're left with Y squared over 144 minus X squared over 256 is equal to 1. For example C, you have a hyperbola with a vertex, or actually, yeah, let's do that. We're going to do a vertex of 0, 9, so that means A is equal to 9, and a covertex of 7, 0, so B is equal to 7. Your A is in the Y place value, so you're going to do Y squared over A squared minus X squared over B squared is equal to 1. So that's going to give us Y squared over 9 squared minus X squared over 7 squared is equal to 1. So that just simplifies to give us Y squared over 81 minus X squared over 49 is equal to 1. For your last example, you have a hyperbola with a vertex of 8, 0 and a focus of 10, 0. So A is equal to 8, C, because it's your focus, is equal to 10. So we are missing B. We're going to use A squared plus B squared is equal to C squared to find B. That's going to give us 8 squared plus B squared is equal to 10 squared. Your 8 squared is 64. Your 10 squared is 100. Subtract your 64 over, and you have that B squared is equal to 36. Again, we don't need B because we're going to use B squared. That 8 in our vertex is in the X place, so we're going to use X squared over A squared minus Y squared over B squared is equal to 1. So that's just going to give us X squared over 8 squared minus Y squared over 36 is equal to 1, which gives us our final answer of X squared over 64 minus Y squared over 36 is equal to 1.